As we said before, the way of searching for a specific protein structure of course depends a lot on what data you already have. Let us assume we know which protein we would like to have a look at, for instance, the molecular chaperone DNA-K from E. coli. The first step would be to go to UniProt, enter DNA-K in the search field, and see which results this yields. As you can see, it lists many popular organisms to the left. We're very lucky that the one we are looking for, E. coli, tops the list of our search results. In order to browse further, we click on the entry and are taken to an overview that lists a lot of data about this particular protein. We will not explore all these data, links and references, but focus on the two aspects we are interested in, the structure and the cross-references. In this case, it is easier to immediately look at the cross-reference because structure as such does not give so much extra information. When you scroll down to the structure section, you can already see a 3D impression. Later on, we will use our own visualization tool to see the overall structure of the chaperone. Here you can see the entries where the structures are listed. Down here in the secondary structure, you can see whether you have a helix or turn or beta strand. Let us explore the rest of the page. Here you see a very nice overview of all the crystal structures and animal structures available. If we zoom out, you can see this chaperone comes with a long list. This in itself is of course already a rather difficult exercise. How would you filter out the structure which you prefer or which you want to investigate further? Unfortunately, there is no magic bullet solution. One option would be to look at all of them, but if we're talking about so many, this will take a lot of time. Sometimes, however, this is a necessary evil, as it is not easy to find those structures you would like to look at. So, what is a general kind of way to approach it? Well, usually, you look into the structures which have a low resolution. Sometimes, you also look into NMR structures. In our case, we go for the crystal structure. These here on top of the list are the older ones, and here you see that they have between 2 and 2.8 angstrom resolution, which is quite good, so this is definitely an interesting case. Just for reference, I would always take the 1DKX, which is among the first ones that were resolved. It has a very decent resolution of 2 angstrom. Here you see that it doesn't cover all of the protein. In fact, it covers only one part of it. This is one way of looking at it. In this particular case, you have a very long list of newer, so to say, crystal structures, which does not make this a trivial exercise. You could argue that you want the lowest possible resolution, for instance, which usually also goes along with the lowest possible R3 factor. In this case, we could take, for instance, the 4EZ series, for instance 4EZX, with 1.7 angstrom resolution, which is very low, so that's quite good. This could be a strategy. On the other hand, however, you could also argue that this is only part of the protein. If you want to have a protein that's decently resolved, so with a reasonably low resolution structure, then these ones here could be other candidates, 4JN4 and 4JNE. Then of course, the strategy is that you pick out those which you prefer from this rather rough selection, download them and compare them, as we will see later on in other exercises. It's also worth mentioning that it's very important to look at the papers, because there might be good reasons why, for instance, the crystal structures have been resolved over and over again. Even if we could say, oh, we already have one, an old one even, this sometimes is the reason that you want to have a full coverage of your primary structure. On the other hand, you also have cases where the protein is resolved in very specific conditions, and this can also lead to conformational changes. Therefore, it's also very important to download the structures, visualize them and compare them, which we will see later on in the course. It's always good to take the original paper about the crystal structures you want to analyze and look at the conditions under which it has been resolved. This can also give you an idea whether it fits the purpose you research with your biological questions.